Hey everybody, my name is MrCaproni and this is AP Statistics. This is the first official video in the series, so I hope we can dive right in. We're going to cover a lot of stuff today, but remember, if you're trying to catch up on your AP stats, go ahead and click the subscribe button, and every week you will find more videos for this class. Now, what are we covering today? Well, first off, we're going to look at what is statistics. We're going to cover the 5 W's for statistics. We're going to look at different types of variables, and then we're going to talk about where we go from here. So we got a lot of stuff to get into, so let's just dive right in. All right, so what is statistics? First off, there are actually 2 definitions for the same word. There's one that deals with like the overall study of statistics, like the class itself or the discipline. And the second one is actually just a term within the class. So first off, let's look big picture statistics. What are we looking at? Well, really, statistics is just a way of reasoning through our world. It's a way of using a bunch of rules and calculations to make sense of all the stuff around us. Without it, you could just say or do whatever you want, and really there's no way to see if it's valid or even true. Whereas the second type of statistics is more of just a term where I say, hey, if I'm collecting a bunch of data from a sample, the statistics are the actual calculations I'm pulling from that data. So we're talking like mean, median, mode, your maximums, your minimums. Those are all statistics we can pull from a sample. See, people like to try to scare others with statistics by confusing them or thinking that there's a lot to it when really there's not. Sometimes people think that people just make up numbers and throw them out there and they're like, oh, the stats say this. Well, I can make the stats say whatever I want. If you are actually following the correct methods of statistics, that's not the case. And if you know how to check information where other people are feeding it to you, you'll know if they did it correctly or not. So starting off in our textbook of what we're using this year, there's 3 major parts to the model that we'll use for our statistics. First step is to think. You want to think first, know where you're going and why. We're going to base a lot of the decisions we make around where we want to go. We don't want to produce poor results or get results that don't matter towards our overall question. We want to know what it is we're studying and why. Second off, we want to be able to show our information. We want to be able to put it in a way that isn't confusing to the general public. You don't want people to look at these numbers and be like, I have no idea what that means, but it looks smart, so we must be right. No, we want to display the information in a way that people will be able to understand. Lastly, we want to be able to tell what it is we found. We have to be able to find a good way to communicate our findings to the world around us. That may mean explaining it. It may be deciphering our conclusions that we come to. But our end result is to help people understand what it is we found. So we need a good way to tell them what that is. Now, where is this information going to come from? It's going to come from the data we collect. Now, data can be any type of thing. It can be names, it could be records, it could be numbers, any type of thing that you can pull from a situation. Now, here's the problem is data is completely useless if it is out of context. So to put it in context, we use the 5 W's to see where we are. Who, what, when,
where,
and why. And then we talk about how we collect all of those with the word how. So when we're looking at each one of these, I'm going to break them down individually so we have a better understanding. Starting off, the who. Now, a lot of students confuse the who and the what, but the who is who we're actually gathering the information from, whereas the what is the actual information that we're gathering. So looking here, you can see the who does have some specific vocab that goes along with it. Usually individuals who answer a survey we call respondents. People who we do experiments on are either subjects or participants. And a lot of times when we collect all this stuff from other objects that aren't human, we refer to them as experimental units. Now, the what is what we're actually collecting from the who. And we refer to those items as the variables. And variables can really be measuring anything. It could be anything from collecting the names of whatever our subjects are to their weight or their height or anything like that. But remember, a variable in mathematics is the thing that changes. Well, what it is we're measuring is the thing that's going to change with each one of our subjects. So we refer to it as the variable. There are two types of variables. First off, there is categorical, and then there's also quantitative. Here's the difference between the two. Categorical is really any type of category you can place your subject into. So a lot of times those are labels, like for example, your race, your gender, anything like that. Now, a quantitative variable is more something you can measure. So that's looking at height, weight, age. Those are things I can actually count and actually measure in some way. Now, don't get confused because a lot of people like to think that if it's a number, obviously it must be quantitative. But as you can see here, identifying identifiers, identifier variables are actually categorical variables, but a lot of times they include a number. For example, let's say I have a room number here at school. My room number is 1242. Well, guess what? That's not actually measuring anything about my room. That's just a label that we've given it. Now, we also have things like social security numbers and other things like that. All of those would fall under this. Those are actually categorical because they're not measuring anything. In reality, it's just another type of label we put on people. So it falls under categorical. Let's go ahead and check these bad boys in action. Now, looking here, you can see a data table, all right? All the way over on the left-hand side, you can see the names of all the people that they collected data about. Now, notice each column is a different variable that we measured, whereas all of those variables kind of have to deal with the same row of the person, which is our who. So usually they place all the different who's in each row, and then you have all of your different what's, the actual variables, in each column. All right. So when we're looking at this, name, what type would that be? Well, name is a label, so we're probably going to say that's categorical. What state do they live in? Again, categorical. When we're looking at price, we're measuring how much it is worth, so that is going to be quantitative. Area code may seem like it's quantitative because it's a number, but really it's another one of those identifiers, so we're going to also label that as categorical. Then as we move through, you can see the rest of these are actually going to fall under categorical. When we do have categorical data, sometimes it's better to use a frequency table instead of a whole data chart like what we just saw. As you can see here, we've separated the different categories that people could fall into. So in this case, we're talking about shipping methods. You can either get it shipped to you via ground, second day delivery, or overnight. And it tells you how many people chose each one of those. A frequency table, instead of giving you all the information for each person, tells you how many people chose each option. So let's go ahead and wrap up with the rest of our words here. The why kind of shapes the way we think about what it is we're looking for. And a lot of times this is what we use to choose which variables we want. At the end of the day, we have a goal of what we're trying to measure or what we're trying to see. So that's really going to help us see why we choose the variables we choose. Next off, we have the when and the where. A lot of times the when and the where really isn't going to make a difference as to our end result, but it does give us some nice information and context of the question, which a lot of times numbers are useless unless you know them in context. I can tell you that there is amount of money somewhere, and I could say that is anywhere from $5 to 300 million. Well, guess what? $5 seems like absolutely nothing, but maybe it's you found $5 in your couch. Now that's really important. Or 300 million seems like a ton, but maybe I'm talking about how much the US spent on education in the past year. In that case, 300 million for all Americans might not be very much. So context is always very important. The last thing we have is the how. The how is actually how we gather this information. And that's usually what adds to the validity of what it is we're collecting. A lot of times the how decides if this is good insight or just complete nonsense. The how is also how people try to lie using statistics. So when you want to go out and ask and see if something is valid, you want to know the how on how they collected their data. And that's going to give you some really good information to whether or not they're telling the truth. So let's recap on this video. First off, we looked at what the heck statistics was. Then we went through the 5 W's plus our how and how to deal with gathering information. We also looked at the different types of variables and made a differentiation between quantitative versus categorical. And at the end of the day, where are we going from here? In the next few chapters, we're going to talk about how we can take that data that we've collected and organize it in a graphical way so that people can understand it to the best of their ability. So I hope you continue to follow me. Remember, if you got anything useful today, go ahead and click the like button and click the subscribe button to keep getting these videos each week. Again, thanks for joining me. My name's Daniel Caproni, and this is AP Statistics.